All right, so we're going to finish up the review today. We're going to look at chapter 3, which is composition functions and composite functions. And then the little bit of chapter 5 that we do prior to the end, which is basically inverse functions, which really relate to composite functions anyway. So, and we did talk about a little bit about inverse functions the last class. We're going to actually be able to figure out how to actually find them and those type of things. And then next week we'll start on chapter 4, which is the new stuff, and the first thing that your actual test will be on. In Alex, D's, all the prerequisite stuff is going to be due on Sunday. On Sunday at 11:59, midnight, whatever the transition time is. Those will lock. Chapter 4 will unlock. Any topics that you haven't done in the previous those sections that are needed as prerequisite skills for stuff in chapter 4, you will be able to do those in chapter 4. It'll fill in the holes. So it's not like they're locked forever. You never get to do those again. So everything you do in it will continue to improve your pi score and continue things to go up. I believe there will be it's set it so that there's a knowledge check at the end of every major unit. So there will be a knowledge check at that point, which can do one of two things. So if you haven't used Alex before, knowledge checks are basically like that initial one you took. It just figures out what you know. Now, that knowledge check can keep you where you are. If it's exactly where you're supposed to be and you know everything that you've already done in Alex, it'll then master those topics so you now have them mastered and you're good with those. If you have forgotten some things or need some extra practice things, it'll give some of those topics back. They will only have 3 bars on it instead of 5, and you just review those topics and get them back pretty quick, and then you move on. It also can do the opposite thing. It also can give you topics that you haven't done yet. So if you've been behind and stuff, but you've been paying attention to class and really understand stuff, but you really haven't done much in Alex, when you take that knowledge check, you might now know stuff that you didn't know the first time you took the initial knowledge check. So you can get topics mastered that you've never even looked at before. So that also can happen. And I have seen that happen quite often on that first knowledge check, because there's so many topics that you had to go through. And sometimes you just don't get through them all, but you understand how to do them now. So you can gain topics on a knowledge check as well. So just keep that in mind. Don't freak out, but do the same thing. Really try and practice on it, because that's how you're going to master those topics and be able to really move on and fill in all those holes that you might have had. All right, so composite functions and composition functions. So composite functions are just basically putting functions together using addition, subtraction, multiplication, and division. So there's a couple topics on this one. Addition, subtraction, multiplication are separated from division because division has to do stuff with domain, where we have to add that stuff in there because we're dividing and you can't divide by 0. So but we'll look at the multiplication, addition, and subtraction one first. They're pretty straightforward and simple. This one doesn't actually have any real addition or subtraction in the actual functions. So we've got 2 functions, g of x and h of x. First thing I wanted you to add them together. So it says h plus g of x. That's just adding. So my suggestion when you're doing these, this one doesn't really matter, but in some of them it does. Always put parentheses around it when you're putting them together originally. So I would do for 4x to the third plus x squared, and then remove them. The addition, it doesn't really change anything. The subtraction one does. So, and one of the things that I have seen people mess up on is when the subtraction piece comes into play. So that's how that one would be written. Actually, I'm going to make one change. I'll do it another slide. Because I want to do one with the subtraction one in there so you can see it. So then we have h minus g of x. Same thing. It's the 4x to the third minus x squared. These, there's nothing I can put together. There's no like terms. So you're just going to rewrite it at the end. I will do one with like terms in a second. The multiplication one has an extra step. You'll always have one in this topic that will have an extra step that as you want to evaluate that function at a specific number. It is not always multiplication. It could be any of the 3. So I'm going to show you multiplication one. It's the same thing. You just basically multiply them together. It's 4x to the third times x squared. Now this one, we can actually do something to it. When you're multiplying like bases, what do you do with the exponents? Add them. So this is 4x to the 5th. Now this is -1, so we're just going to plug -1 into x. So -1 to the 5th power is -1. So this is going to be -4 would be my answer there. Okay. All right, I'm going to do one more because I want to do not. I'm not even going to. I'm going to make one up because I want one with the actual numbers that we can put together in there. So.
Oh, yes. Sorry.
I just saw you still writing, so I didn't want to switch over if you were still writing something. All right, let's do 3x squared plus x minus 1. All right, so let's do f minus g of x on this one. So same thing, we put them together. This is one of those ones, if you didn't put the minus sign, you might forget to change that. If you had just wrote 3x squared minus plus x minus 1 minus 2x squared plus 5, you might forget that one when you're putting them together and you might get the wrong answer. That's why the parentheses kind of help, because it forces you to remember, oh, I have to do distribution. So now we have the 3x squared plus x minus 1 minus 2x squared minus 5. And now I can combine like terms. So 3x squared and 2x squared is x squared plus x minus 6. And that would be your final answer for this problem. So that's the only reason I put parentheses around them, is just to, it just gives you that brain an extra step. It's like, oh, I have to do something with the parentheses to get rid of it. And it's especially true in the subtraction. Any questions on those before we go to division, which is the harder one? Okay. All right. So in this one, they want us to do h divided by g, and then they also add in the 1 there. So division, this one's pretty straightforward. We'll have a little more complicated one in a minute. So we have x plus 1, x minus 4, divided by x minus 8. Nice thing, this one's completely in factored form at this point, so we can see easily if we have to cancel things out. There's nothing I can cancel out in this problem. Now they want us to evaluate this at 1. So we're going to plug in 1. So we have 1 plus 1 is 2. 1 minus 4 is -3. 1 minus 8 is -7. So we get -6 over -7, which is 6 sevenths. So that would be the plugging it in and solving. The bigger thing that comes into play when we're having the division is we have to find domain, because you can't divide by 0. When you're looking for domain, you actually have to look for the domain of every function that's there. So if something does not work in h of x, for example, it will not work in h divided by g of x. Okay? So in this case, is there any number that will not work for h of x? Huh? Well, everything will work for h of x. Yeah, you're one step ahead of me. So it's a polynomial, any number will work. There's no division. There's none of those restrictions that we talked about last class. And the same thing with g of x. There's none of those restrictions that'll work on that one. Now, when we put them together, however, I do have to look at what's going to make the bottom 0 in this case. So in this case, that is that x equals 8. So 8 will make my denominator 0. So 8 is not a member of my domain. So x does not equal 8. Okay. Let's look at a harder one now. So in this case, we've got two rational functions. Rational functions are division. Rational functions are going to have a domain restriction built into it. So the first thing we want to look at is the f of x. Which values will make f of x not true, or which values do not exist in f of x? Yes, x cannot equal -8. Which values cannot work in g of x? 0. Okay, so now we can set them up. So we have 2 over x plus 8 divided by 9 over x. Now, is there any other value that will make 9 over x 0? In this case, no. I'll make one up that does in a second. So now we want to simplify this problem down. So remember, when you're dividing two fractions, you take the first one, flip the second one, and multiply. So I've got 2x over 9x plus 72. And no value should pop up after you simplify it. You should have already taken care of those problems in the original problem. Okay. So in this case, that's my answer, and my domain restrictions are x cannot equal -8 or 0. Another one. Another one. Yeah. Yep, that's the one.
This is basically the same thing as F composite G.
No. No, this is so we have the composition and we have the composite and combinations. That's the other. That was the other two where I was trying to think of. This is the combining one. This is combining functions. We will do the F composed of G and F G composed of F and those in a minute. I do one more of these though. All right. So let's look at this one. So again, we're going to do F over G of X. So what are the restrictions for F of X? -7. What's the restrictions for G of X? 4. Now, if we set this up, we have 6 over x plus 7 divided by x over x minus 4. Is there any other value that will make the denominator 0? Yes, 0 will make it 0. Okay, so in the last one, I had a 9 on top and it didn't make a difference. However, in this case, if I put 0 as x, I have 0 on the bottom of this denominator. So now x equals 0 is also a domain restriction for this one. Okay. So now we have the 6 over x plus 7 times x minus 4 over x. So 6x minus 24 over x squared plus 7x. And that's that answer. And then my domain restrictions are -7, 0, and 4. So that's the extra piece that you have to do. Sometimes there will be, you also have to look at the numerator in that case because it's on the denominator, it's on the denominator of the new rational function. I know I'm going through some of this stuff pretty quick, but
You don't have to simplify it, do you?
that's as simplified as you can get, actually, in that respect. There's nothing you can cancel out. If you can cancel something out, cancel something out. In this case, I can't cancel anything out. No, don't want to break it into two in this case. You want to leave this as one. A couple things. I said this is as simplified as possible, and it is, but there are things some people try to do and cause problems. I cannot cancel those x's. Okay? I've seen people try. You can't do it. Okay? Same thing is I can't like say, okay, I want to do 6 and like, or in this case, none of the numbers work, but you can't simplify in a fraction like that. It's got to be multiplication. I can't like cross that x and that x out because they're first in the problem. All right? So don't try to do those type of things. I've seen them before. So that's why I'm mentioning that. So just puts that little bug that you can't do that in your ear. I need to do that one. I've already done that one. All right. Any other question on combining functions? We good with that? All right. All right. This is what's known as the difference quotient. It's also known as slope. So for those of you that are going on that need more math classes and going on to calculus, this formula right there is the basis for all of your differentiation in calculus. Okay. That will be one of the very first formulas you're going to see in calculus to use. We do it in pre-calculus, actually not for that reason, just because it's actually a really good problem to looking at using function notation and how to simplify problems down. So let's actually look at this problem. So you've got, remember, x plus h means I'm going to plug in. Wherever I see an x, I'm putting x plus h. So f of x plus h is negative 4x plus h squared minus 6x plus h plus 6. What's x plus h squared?
Squared.
No. But
Oh.
thank you for saying that. That is the next big thing that always comes into play. Remember, x plus h squared is x plus h times x plus h, which means we have to FOIL. So you've got x squared plus 2xh plus h squared. You have that middle term. Don't forget the middle term. It is very easy to do the x squared plus h squared. So I'm glad somebody said it because I was going to bring it up anyway. But thank you. That is something that another one that comes up quite often in play. So just keep that in mind when you're going through and doing these problems. Really easy to make those mistakes in there. All right, so I'm going to erase this because I need the room. So I've got negative 4x squared plus 2xh plus h squared minus 6 h plus 6. So now I'm going to distribute minus 8xh minus 4h squared minus 6x minus 6h plus 6. Notice I'm not worrying about the bottom yet. I'm not even worrying about this part yet. I'm literally just worrying about the first part. Trying to simplify that down as much as possible. And then I will worry about the other two pieces. I don't think I can combine anything in that situation. So now we're done with that part there. All right, so that's f of x plus h. So now we can plug everything back in. So I've got negative 4x squared minus 8xh minus 4h squared minus 6x minus 6h plus 6 minus negative 4x squared minus 6x plus 6. So now we can clean up the top. I would totally rewrite this. I would just go through. It's like, okay, so that's going to be a plus 4x squared plus 6x and minus 6. So what that does is that's going to cancel with that. That's going to cancel with that. And that's going to cancel with that. So we're left with negative 8xh minus 4h squared minus 6h all over h. Have I lost everybody yet?
What's H?
H is just the term they used. So h is actually going to be the difference between the 2 points. So if this was slope, it's x1 minus x2. The point where you use this in calculus is because the point of differentiation is getting that change to be instantaneous so that there's nothing between those 2 points. So the one difference between what we're looking at right here and what you're going to look at in calculus is in front of it, it will say the limit as h goes to 0. So as h gets infinitely smaller, basically to 0, what happens to the function? So in this case, now we're going to take out one of the h's because I don't want h down the bottom. So everything's got an h in it. So I'm going to cancel one h out of everything. So I'm left with negative 8x minus 4h minus 6. And that's the answer to this question. And that's the derivative of the function. Notice this similarity in there? What's the only thing that's not in my new problem down the bottom? The 4h. And if h goes to 0, it's 4 times 0. 0, so that's gone. So what's left is the negative 8x minus 6. That's your 2/3 of Calc 1 is basically teaching you how to do that. And why, obviously. No, the final answer is negative 8x minus 4h minus 6 in this. For your calc class, negative 8x minus 6 would be your answer.
How do you get rid of the H?
You're doing the limit as h goes to 0. So as h is now 0, you can plug it in and get the answer. So almost all of your Calc 1 class is basically explaining how to do that and why you're doing that. That's why we show you that formula in pre-calculus. All right. Now on to composite functions. And inverse functions. So composite functions are when we take one function and plug it into another one. So in this case, we're taking R of 2 and plugging it into Q. The first few topics that they do on this, they're giving you it in terms of numbers. So you can plug in the 2 to the R, find the answer, and then take that answer and plug it into the Q. So you're doing it in steps. So the first thing we're going to look for is we want to look just like PEMDAS. You start in the inside and work your way out. So I want to figure out what R of 2 is. So I'm going to take R of that one and plug in 2. So negative 8 plus 1 is negative 7. Now that Q of R2 is negative 7. So that now replaces with negative 7. Yes. Oh, it's negative 1. All right. So that would be negative 9. There we go. All right. So we're going to take the negative 9 and plug it in there. So now I'm going to do Q of negative 9. So Q of negative 9 is negative 2, negative 9 plus 1. So my final answer, so Q of R of 2 is 19. Be careful on the letters. It is not always going to be in the order they list them. They could have easily done R of Q of 2. Okay, so just keep that in mind when you're working through. Yes, on purpose. So it's a matter of working through the process. It's do one piece at a time. Don't try to do the entire thing, and it'll make more sense. Let's do another one of these. Before I move into all right, so try this. All right, try this one. Which function am I doing first here? S. So I'm going to plug in 1 or negative 1. Negative 1. Yep. So now I have t of negative 1. So negative 2, negative 1 squared minus 1 is negative 3. Because negative 1 squared is 1. 1 times negative 2 is negative 2. So final answer is negative 3. This topic's actually asking you the exact same thing. The only difference is how they write the problem. They use the composite icon. So this is so Q of R of 4 is the same thing as saying Q R of 4. Those mean the exact same thing. So it's Q composed of R or Q of R of 4. Basically, it's how you read it. So they mean the exact same thing. So in this case, I'm plugging the 4 into Q. So I have 4 squared plus 4. So that's 20. And now I'm taking the, oh, I did it backwards. The other one. Okay, I'm plugging the 4 into R. So that's the square root of 9, which is 3. And now I'm plugging it into the Q. So 3 squared plus 4 is 13. The other one would be R composed of Q of 4. So it's the same thing, just reversed. So now it's the r's on the outside and the q's on the inside. 4 plus 5 is square root of 9.
Oh,
So now we're going to plug it into the q. So 4 squared plus 4 is 20. And then we do the r of 20. So equals the square root of 20 plus 5, which is 5.
what if you took the 4 away and just put Q of R?
You can't ever have q of r. You can have it be of x. And actually, yeah, we can do that. I'll do that. So you can have it look like this. Q composed of R of X. So in this case, same thing. That's just Q of R of X. What's R of X? Is the square root of X plus 5. Right? So now I'm going to take that, plug that into the Q. So now I have that equals, so square root of X plus 5 squared plus 4. Square root and square do what? Cancels each other out. So that's X plus 5 plus 4, which equals X plus 9. So that would be what Q composed of R of X is. So you can just plug in the
Is
functions.
there a
So
way to make it bigger to then do that X of 4 and plug that into R? I feel like
what do you mean?
college algebra, where you would then, it's like written like 3 words, like Q of R of X, and then find that out what X of Q would be.
I can compose 3 functions. So if there was 3, you could do 3. So it could be Q of R of H of X. You could do that, and then I could tell you X is 5, and then you could plug that into that problem. So in this case, X is 4. So if we did 4 plus 9, you get 13, which is what we did before. So you can have them find you the X term and then have to find, they give you a value for X and you have to plug it into that. That could happen. But in all honesty, this is about as complicated as this gets. It's like plugging things in. The only thing that can get more complicated is where they confuse you by plugging the same thing into itself, which is what I'm about to do now. So, which is just confusing more than hard. So in this problem, they want us to find G of G and H of H. So G of G of X is the same thing as saying G of X. So one of the there, do you have to do it like this? No. You have to write it out like this? No. They just want the answer. One of the reasons why I write it out like this sometimes is because it kind of forces you to plug things in the correct order. Especially when they're the same letter, it's really easy to screw up where you're plugging things in. So that changes to that, and this is going to change to that. So I'm just replacing that piece inside. Now, that means I'm going to take G of X, and wherever I see X, I'm going to put X squared minus 4. Actually, what am I going to do? we're going to do this a little different. I'm going to actually use colors. Because I think colors are going to help in this case. So that equals, I have x. So I'm going to put x squared minus 4. Squared minus 4. So I'm replacing the x with x squared minus 4. Does that make sense? So now FOIL this out. X to the 4th minus 4x squared minus 4x squared plus 16 minus 4. So that's my final answer. Sometimes colors help. Colored pencils are great, especially when you're trying to start combining things together. Doing it in different colors can be helpful to see where you're combining things and where you're doing things. Even in my calculus classes, when we're doing multiple substitutions and things like that, using colors can help you organize your notes so you know what you're actually doing. So that's not a horrible thing to actually use in math class. Pick up a cheap pack of colored pencils at the store and use them to go through and do your notes. So highlighters work too. If you like highlighters, just highlighting certain things in colors. Things to organize so you don't make those little mistakes. Let's do the g of x, or the is it h of x? Yeah, let's do the h of x now. So the h of x is the exact same thing, except it's a fraction. So h composed of h of x is h of x. So that is h of x over 2. So I'm going to take that original x there, and I'm going to replace it with x over 2. So this becomes x over 2 over 2, which reduces to x over 4. So it's x over 2 times 1/2. All right. Any questions with that? Okay, let's do a little bit of work with domains. All right, so they're looking for G composed of F of X. Okay, so they want to know what the domain and the range is. If we were doing this problem, remember we start from the inside. So the F of X is first, right? And then whatever I take from that number, the F of X is now going to be going into G of X. So let's start with 1. If I plug in 1 goes to 3, correct? Yes? So now I'm going to go over to 3, and 3 goes to 0. Okay? That makes sense to everybody?
Yeah.
All right. So my first point is 1, 0. Because if I plugged 1 into the function at the end, I'm getting out 0. There we go. Now I've got the Good. So remember the whole point is going across, right? So if x is 1, so if I'm taking, that's 1, right? So that's out of x. So if I plug that in, doesn't matter what fx is, I'm going to get 3. So now I take that 3 and I'm plugging that into g. So now if I plug 3 into g, I get 0. So my initial number I plugged in was 1. My answer for the problem was 0. Okay? So far right now, 1 is my domain and 0 is my range. Yes. So now let's do the next one. So if we do 4, 4 goes to 6. Is there a 6 in G? No. So 4 doesn't work. Next one, 7. 7 goes to 7, and 7 goes to 0. So my next one is 7, 0. Final one, 8 goes to 7, 7 goes to 0. So 8, 0. So my domain for this is 1, 7, and 8. And my range is 0. Okay?
I feel like writing it out like that, the circles and
Helps.
helps.
Well, it depends on how you do it. Depends on how you think. So you don't have to do it with the circles, but going across does matter. So, and making sure that you have the right ones. Like, honestly, those isn't, but that's the important piece. Because that's your X and that's your Y. That's the beginning and that's the answer. Because that's how you're going to get your domain and range. Okay? So basically, you're going across. And not every number is going to work. Like in this case, the 4 didn't work. So you can't just say, oh, my domain is the first one, my range is the last one, because that's not necessarily true. So, all right. Because 4 went to 6. So when I plugged in 4, I get 6 out for f, right? I get 6 out for f of x, correct? But g of x, 6 isn't part of its domain. So when I try to plug that in as a function g of x, it doesn't work. So there's no answer to it. So that would be a domain restriction for f composed of, or g composed of f. Okay?
Basically putting your X as the number of your domain.
Yeah. Oh, I didn't write it in set notation. Fine. I don't care. Just give me another problem. So here, just to make sure you don't make this, I didn't really care, but you have to make sure you use the little set notation when you type it in. Don't just type the numbers. Hit the little braces. I just wanted another problem. All right. Find my domain of G composed of F. The nice thing about this problem is it's always going to be in the order they gave you the circles. You're never going to have to try to move them around. So you're always basically going from left to right. Nope. Just the one. So it's G of F. So that's what I'm saying. It's always in the order they gave it. So that would mean you do F first and then G. This is one of those problems that they don't try to confuse you. No, I know. I know. I didn't copy that part off. So 0 goes to 1. There is no 1. So 0 doesn't work. 4 goes to 4. 4 goes to 2. So 4 goes to 2. 6 goes to 6. 6 goes to 2. 7 goes to 2. There is no 2. 8 goes to 5. 5 goes to 5. 9 goes to 0. 0 goes to 5. So I've got 4, 6, 8, 9 is my domain, and 2, 5 is my range.
Yeah, right twice.
No, you do not have to write them twice. All right. Last one for composite functions before we go into indices. Oh, actually, I might do one more. Yeah, I'll do one more. All right. So the next thing they'll give you is the functions, and then they're going to want the composition, and they want the domain. So it's G of H of X. So it's G of X minus 5. So I've got 5, X minus 5 plus 30. So we can simplify that down a little bit. And we end up getting 5x plus 5 is the final simplification of it. So that's the answer for the first part. All right. Second thing, when we're looking for our domain. So if you think back to the problem we just did a little bit ago with the bubbles, the first thing you want to look for is what is the domain of the original problem, right? So in this case, is there any domain restrictions for h of x? Because that's the one that I'm plugging in. No, that one does not have any domain restrictions. So we do not have to worry about that one. The next one would be, what's the domain restrictions of the final answer, when we're plugging it in. So you want to do this before you simplify. Because sometimes when you simplify, you get rid of things that can cause some problems. So go back and look at that original problem once you first plugged it in. So in this case, is there any domain restrictions for that? Yes, it's a square root, correct? And square roots can't be negative. So I've got to look for numbers that have to be greater than or equal to 0. So my domain restriction is going to be 5 parentheses x minus 5 plus 30 has to be greater than or equal to 0. So in this case, the simplification really didn't change much. So x has to be greater than or equal to -1. So if we do this in set notation, that would be my domain. Okay. All right. Any question on composition functions? Okay. Let's look at inverses. All right. We talked briefly about inverse functions last class. When I mentioned the horizontal line test. So horizontal line test states that as long as there is one output for every input, and for every input there's only one output, it would have an inverse. Basically, another way to look at it is saying it's 1-to-1. So function notation just means that for every input, there's exactly one output. For an inverse, though, we have to look at the opposite as well. We have to make sure that for every output, there's only one input. So I can't have two things equal the exact same answer out. That's what 1-to-1 is. So if we look at graph 1, is graph 1 1-to-1? Yes, we can use what's the horizontal line test. So first off, make sure it's a function. That's step 1. And then we can use the horizontal line test to say the other direction, see if that works. In this one, it passes both the vertical and the horizontal line test, so it is 1-to-1. Graph 2. So for every input, there's still one output. It's a function, right? And if we go the other direction, there's no point where it hits more than once. There is a gap, yes. But it could be a piecewise function. That's possible. So yes, this would be 1-to-1. Graph 3. Yeah. Graph 4. Yes or no? No, because if we go across, it's going to hit more than once. Graph 5. No. Graph 6. No, because we're right there. Okay. So that's just using the horizontal line test. However you did the vertical line test, if you used a pencil, just looked across, whatever way you did it, just do the opposite for the horizontal line test. All right. So are these inverses of each other? So an inverse, when you're looking at inverses, if we put them together, so again, we're going to be doing those composite functions. It's where we see f of g of x and g of f of x. When you put them together, you should get x. Just x when you simplify the problem down. No negatives, no numbers, no addition, nothing. Just x. As long as they both come out to be x, they're inverses of each other. Okay? So let's look at the first one. So we would do f of g of x. So in this case, they're both the same. So that's going to make my life a little easier. So I have f of 1 over 3x. It's 1 over 3 times 1 over 3x. So 3 times 1/3. Oh, actually, not 3 times 1/3. So if I just look at the bottom, I have that. Oh, I flipped it over and I wasn't supposed to flip it over. So that ends up being just 1 over x. So then I have 1 over x, which is just x. So that's x. And the nice thing is, in this case, they're exactly the same. So doing the other direction is going to give you the exact same thing. So that is an x as well. So in this case, f and g are inverses of each other. Okay, so, because it basically means that what's an inverse do in addition? Right, but so if I take the inverse of 2 and I add them, I get what? Nope. If I add them, I get what? 0, because it cancels itself out, right? If I did multiplication, the inverse of multiplication is division, right? If I put those two things together, I will always get 1. So if I take 2 times 1/2, I get 1. When you're taking the inverse of things, it cancels stuff out. An inverse of a function cancels everything out. So it goes down to x, because it cancels out all the rest of the actual calculations. Okay? So it basically collapses it down to that line.
So it has to equal the variable x.
Has to equal exactly the variable x. It doesn't, it's not that it equals the same thing. It has to equal x. There are situations where you'll get the two problems come out to be exactly the same thing. They'll equal x plus 2 and x plus 2, or whatever it happens to be. Or they'll equal negative x and negative x. Those are not inverses. It has to be exactly x. Yes.
Also, question: if f of x and g of x are the same, are they always going to be inverses of each other?
Let's find out, since these are the same. So I have f of x plus 2. So that means I have x plus 2 plus 2, right? So I have x plus 4. So they're the same. So this is going to also be x plus 4. Are those inverses?
Yeah.
What did I just say? It has to be just x. So no, these are not inverses of each other. They do not, it's not that they're the same.
Oh.
They have to be x.
So if it was just x. But then
Correct,
they
like the
were
last
inverses.
one.
In this case, one of them would be -4.
Right. In this case, they were both x. So they are inverses of each other. In this case, they're the same, but they are not x. So they are not inverses of each other. Okay? That make sense? Okay. The reason I do this first is because once we start looking for inverses, you want to be able to test them to make sure they are actually inverses of each other. This is how you test it. You plug them back together and see if they give you an x. Okay.
Also, another question about the last one.
Yeah.
Forgot to ask the x is not equal 0.
What do you mean?
That one.
Oh, yeah. X can't equal 0. That's just the domain.
Alright.
Yeah, that's just the domain restriction. They have to put the domain restriction in there because of, yeah, it's a fraction. Yeah, let's do that one first. This, that's a symbol for inverse. Okay, if you see the -1 up there, that's a symbol for an inverse. It is not the reciprocal. So remember, when you're doing exponent rules, if you have x to the -1, that means it's 1 over x. Okay, when you're looking at function notation, that means the inverse. That's why in sine -1 is the inverse of sine, not cosecant. For those that remember their trig stuff. So that is a symbol for inverse. To find an inverse, we switch x and y. So we're going to rewrite this problem as y equals the square root of 1 minus x plus 2. To do my inverse, I'm going to switch x and y. So it's going to be x equals the square root of 1 minus y plus 2. Okay, so step one when you're looking for inverses is you switch the x and the y. Now I have to solve it for y. So what's the first step? Minus the 2. Next step. How do I get rid of a square root? Square both sides. You do not have to multiply this out. You don't have to FOIL this out. You can leave it just like this. You can if you want to, but you don't have to. Next step. Minus the 1. Is y by itself? Nope. There's a negative sign, so I got to swap the signs.
What if you were to put the -1 in front of the x?
Doesn't matter. As long as the 1 is negative in that respect, it doesn't make a difference. You had to put -1 plus x plus or minus 2 squared. So I got this. So that is my inverse.
Why does that one change positive?
Because I'm changing the negative sign. Yeah, I'm changing all the signs. Now, this one's got that piece right there. So remember, the square root function doesn't exist when it's negative, right? So this case, it only exists from -infinity to 1. Inverses are inverses of each other. So if I looked at this function right here, while you're looking at that, I'm going to graph it real quick. you would get this. Is that an inverse? Does that pass the horizontal line test? No. But if we look at it in terms of the domain restriction, now does it pass the vertical line test? Yes. That's why that domain restriction is so important in that respect. Okay? Because that domain restriction still exists when you look at it in terms of the inverse. So you have to keep that in mind. All right. All right, try this one. Oh, somebody could have told me I didn't have it on the screen. Try this one. I look over and I'm like, wait, that's not what I wanted to see. That's what you should have got. Okay, so what's different about this problem than the last one? It's cubed, We don't have a domain restriction, right? Why don't we have a domain restriction? Correct. Okay. All right. Let's do a hard one. The fraction ones are always harder. Also, the ones that have multiple x's are typically harder. Yes. All right. So first thing is they want us to find our inverse. So let's find our inverse. So same thing we did before. We're going to switch the x and the y. And you switch them all. So every x becomes a y and every y becomes an x. And now I have to solve for y. So let's go about doing this. What's the first thing we should try? Yeah, let's get rid of my denominator. So I have x times 7y plus 4 equals 9y minus 8. Okay, next step. What do I want to try next? Well, I have two y's, so how am I isolating it?
9y added to that side.
However, I still have two y's. So somehow I've got to get my y's together. So yes, we do need to isolate it, but I can't isolate, just pick one of them and isolate it because I still have a y. Yeah, let's distribute next. Because now I can move all my y's to one side and all my other numbers to the other side. I'd still have x's in play, but that's we'll deal with that in a second. But now at least I can get all my y's on one side. So we're going to move the 9y over and then the 4x over the other direction. So we have 7xy minus 9y equals negative 4x minus 8. So all my y's are now on one side. Everything else is on the other side. Now what should we do? So you'd have negative 9y plus 7xy.
No, I had 9y minus 7.
Oh, okay. And then you move the 8 over?
Yeah.
Okay, so you have everything reversed. Yes, that's fine. As long as everything's reversed and the signs are literally the exact opposite, that's fine. Well, if I divide by x, I have to divide everything by x. So then I'm going to have an x over here, which is not going to be helpful. Yeah. So now that I've got all the y's together, I can factor out a y. So I have 7x minus 9 equals the negative 4x minus 8. And now I can divide both sides by the 7x minus 9, which gives me my y completely by itself. So that would be my inverse.
If your signs are completely the opposite, is that correct?
As long as your signs are opposite for every one of them.
So if I have 4x plus 8 over 9 minus 7x, that's correct?
You have 4x plus 8 over negative 7x plus 9.
Yeah.
Yes. Yeah. So, all right. the next thing they want us, yes,
Coincidence that the 9 and the 4 plus swap places to negative.
yes. Doesn't always work that way. Yeah, he's still got him positive. So it sometimes it doesn't work that way. So I would caution against trying to find shortcuts after looking at only one or two problems. Because what ends up happening is they work sometimes, and then other times they don't work. And then you get totally lost. I'm one of those ones that if a shortcut's going to pretty much always work, I will tell you. Because obviously it's going to help you. But if there are little tricks and things like that that don't always work, I'm probably not going to mention them just because it's like you have to remember when the trick works and the trick, and it just makes you have to remember more things. So, all right. Now we want to find our domain and our range. So the first thing they wanted to know is what's the domain of my inverse? So we can just look at my inverse function to figure out the domain. We're looking at just the denominator, right? Because it's dividing by 0. So 7x minus 9 has to be greater than 0, or sorry, does not equal 0. So in this case, x cannot equal, was it 9 sevenths? 9 sevenths. Okay. The next thing it asks you is what's the range of the inverse? We haven't asked range very much. Typically because range is very hard to find. Because you have to plug values in and see where like the minimums or the maximums and stuff like that. The reason it asks you here is because it's actually not that hard to find it. So anybody want to take a stab at how they think they found the range?
The x's, 4x, 7x.
No. But good call thinking back to horizontal asymptotes. Good call. Yes.
The range of the inverse domain
Why?
of x, y, z.
Right. I switched my x and my y. So remember, your domain is typically your x, right? And your range is typically your y. But I swapped them. So your range of your inverse is the domain of your original function. So what's the domain restriction for my original function? So we look at that denominator. So it's negative 4 sevenths.
So would it be correct? So I did everything up. I got x cannot equal minus.
You shouldn't have.
Because I got minus 7x plus 9. 4x plus
Right.
9.
So you still should have gotten
Minus 7x times minus 9
Hmm.
over 7.
Hold on. Let me try something. So you had 4x plus 8. And you had negative 7x plus 9, right? No, because you still should have gotten 9 sevenths because you would have subtracted the 9. You still should have gotten 9 sevenths. So, because you would have gotten, you had negative 7x plus 9, right?
Yeah.
So you got negative 7x equals negative 9. So x still equals 9 sevenths. Yeah, you still should have gotten that. I don't care. I just want to go on to the next problem. It's too mystery. All right, 2 more problems. Almost there. So this question asks you to find the inverse of the graph. Okay. So the first thing I would do, identify the points where things change. So I just put my pencil and just clicked on the points that were there. What's the inverse do? It swaps the x and the y. So this point right there is x is -3 and y is 2. So my point is going to be at 2, -3. That's that point. That point's at 0, 4. So my next point's at 4, 0. That point's at 7, 5. So it's at 5, 7. And then connect your dots. And don't forget to erase the extra points you graphed. It'll mark it wrong. Or just write them down on a piece of paper. You don't have to necessarily mark them. But. Okay. So identify the points they give you and just reverse them. That's what you're doing with an inverse.
And there we have a whole bunch of those.
Because those are easy. Word problem.
I can't write all that down.
All right. Leela is walking. The function is her distance in kilometer from Tomsville after T hours of walking. So, what is the X? So, in this case, it's T, but what's the X value represent in this problem? Time, hours of walking, right? What's the Y value represent? From Tomsville. Okay. Now, if I'm looking for the inverse, those switch. Okay. So, the amount of so the question is which one of these is right? The amount of time she has walked in hours when she is X kilometers from Tomsville, the reciprocal of her distance from Tomsville after walking X hours, her distance from Tomsville after she's walked X hours, or the ratio of the amount of time she's walked in hours to the distance times Tomsville. So if you look, this third one is exactly the same thing as the original problem, right? So we know that one's not the inverse. What did we say about inverses not being, they're not the reciprocal? So that's not true. The only one that actually switches it exactly is this first one. Okay, so remember, the concept of inverses is switching the X and the Y, switching the domain and the range. Okay, so now instead of knowing the distance, instead of knowing the hours and figuring out the distance, we know the distance and we're figuring out the time, which is the exact opposite. All right. I'll just zoom in on this one. Find me the inverse of that. Compared to the ones we've done, this one should be easy. Since it's a decimal in this one, keep it as a decimal. So I'm going to still have a fraction, but you can keep this one as a decimal. You can, and it also is exact. So we got. Now I have to use my calculator. So you should have gotten negative 1/4 x plus 3.2. If you put 0.1 or 0.25, that's fine. And then the answer is 1.1 is the final. So it's a word problem, yes, but it's not overly complicated. It just looks like really complicated when you look at it on the screen. So, all right. I've pretty much gone over the vast majority of the topics. I've skipped a few here and there, but the vast majority of the topics I've covered in the review. So remember I said those end on Sunday, and then the chapter 4 opens up on Monday. Okay. Have a good night.
See you Tuesday.